in the programmer's view of memory, that is your segment number and the offset. Let's see. Here is user's view of program. We are having subroutine, stack, symbol table, main program. This is user defined function. Suppose it's sqrt, square root function. So this is your logical address that your programmer view is that you can think just, okay, there may be a stack you have developed. There is a symbol table, subroutine. Subroutine, you can think of your functions, and then there is a main program. So there is no physical address right now here that where this stack is there in main memory, where is symbol table in main memory, where is main program starting in the main memory, and where is your user defined function or predefined functions are there in the main memory. And we don't want to bother about that. Why we go for in detail? Do you remember that proverb in Hindi that आम खाओ गुठलियों से क्या गुठलियां क्या गिनना, समथिंग लाइक दैट? क्या था, मुझे याद नहीं आ रहा. कैन यू टेल मी? वो दैट वाज अ प्रोवर्ब, समथिंग लाइक दैट. आम खाइए गुठलियां से क्या मतलब, लाइक दैट. कुछ ऐसा था, मुझे याद नहीं आ रहा. डू एनीवन रिमेम्बर? डू एनीवन रिमेम्बर दैट प्रोवर्ब? आर यू देयर? किसी को याद है कि आप आम खाइए गुठलियों से क्या मतलब, समथिंग लाइक दैट? आई एम नॉट एग्जैक्टली uttering that proverb. Can anyone correct me? What is the correct one? What was the correct one? Have you ever heard this? Yes or no? Sir, यही था. Okay, cool. सही बताया.
No, sir.
So नहीं तो बताओ ना. What was the correct one? Come on, you can speak or you can.
Sir, I don't know.
Okay, let's move on. So this is the thing that okay, have you studied that object-oriented programming side by side? Do you remember that abstraction? Have you studied abstraction in Java? Abstraction.
Yes, sir. Yes,
Can
sir.
you define? Can you define abstraction?
Yes, sir. Sir, the act of representing the essential details and hiding the background details.
And why we do so?
Sir, because we infinite.
Yes,
So it
but-
makes the program more user friendly.
Right, right. And some more usefulness. There is also a sense of security in that.
This is the complexity.
Exactly, complexity is reduced because users don't want to bother about the minute details about that object. So that is why we and here you can see a live example of abstraction. This is also an example of your abstraction. How this is an example of abstraction? Can you do the reasoning? Who will do the reasoning?
Yes,
How
sir.
this
Yes, sir.
example
The
of
class is
abstraction?
going on. So the
Yes.
class is going on. Your photo is visible. We are all chatting on the chat box.
Mhm.
We can see the essential things, but we can't see how it is all working behind.
Exactly. And can you explain this screen that is user's view of program, how it is an example of abstraction? That is this logical address.
Yes,
That
sir.
you
So
can
we
see
can.
only stack symbol. Yes. Yes,
So
please
yes,
speak.
sir. Yes, sir. We can see the main things done by the programmer, but
Mhm.
we can't see the background details like where the certain variable is stored, where its values is stored
Exactly.
in the system.
Now everyone has got the concept. Picture is clear in your mind. Picture is clear in your mind. Why we use logical address? Excuse me. Sorry. Now everyone is clear. Picture is clear about logical address in your mind. We use abstraction here because we don't want to expose all those things to the normal user, because this may be a threat for the hardware, because everyone is directly interacting with the hardware, then there may be an issue. Do you remember that class where we were discussing microkernel? And I have given you an example that there are a number of students in our faculty of engineering. If everyone have an issue and they can directly go to the dean office or coordinator's office, then there may be a threat for the coordinator. That is, and coordinator, I have take the analogy of your kernel. That kernel is doing all those things, right? Got it? And every student is going for all activity to the kernel, that is your coordinator. Then there may be a threat for the coordinator. So what we did make up microkernel that all the essentials things are given to the microkernel, that is coordinator, and rest of the things are given to whom? His subordinates, like office superintendent.
So you are not audible.
Uh, am I audible? Am I audible? Let me know.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so everyone is good with the example of that microkernel and kernel. Can you relate? Can you relate? Come on.
Yes, sir.
Okay,
Yes,
cool.
sir.
Thank you. Thank you. So let's move on. So here you can see logical view of segmentation. Here is user space and here is physical memory space. Now you can think of this is a square root function. This is your main function. This is your like symbol table or anything. We have make this as segment numbers. Like this is segment 1, segment 2, segment 4, segment 3. And now where they are actually placed into the physical main memory. Now you can see there are certain partitions are there in the physical memory, and you have placed segment 1 into here in this place into the physical memory. Your segment 4 is there and segment 2 is there and segment 3 is there. Means as per your best fit, worst fit, or your like first fit strategy, you can place these segments into the physical memory space or any other algorithm you can use. So this is your programmer's view, that is your user space, and this is your actual physical memory space where we are placing those segments into the main memory. Now, how we are converting the logical address into the physical address, we use a segmentation hardware. So an implementation to map two-dimensional user-defined address into one-dimensional physical address. How this is a two-dimensional user-defined address? Because we are using what? Segment number and tell me. Segment number and second thing what we are using in logical address. Come on. You have seen the tuple. Tell
Offset.
offset, exactly. Segment number and the offset. And offset you can think of as a displacement. So this is your two-dimensional user-defined address. That is your logical address. Now we convert this two-dimensional, that is segment number and offset, into a one-dimensional physical address. How this activity can be done? Let's see. This mapping is effected by a segment table. Now we use a hardware that is segment table. Each entry in the segment table has two things: a segment base and a segment limit. Segment base, just think of your array, that is there is a base address. So here is your segment base, you can relate with your array. And there is a segment limit, means how much area you can occupy. So segment base and the segment limit, you cannot go beyond your segment limit, right? Everyone, all good? Segment base, just think of as your array base address, and segment limit, how much area you can occupy, means what is the length of your array where you can put your values. So the segment base contains what? The starting physical address where the segment resides in memory. Just think your array. Take the analogy of array. Your base address is your starting physical address from where the segment resides in memory, and the segment limit specify the length of the segment. As just I explain you that what is your segment base? It is your physical address from where starting, from where you can starting to putting the values, and what is the maximum limit? What is the maximum area where you can go for? That is your segment limit. So physical address is equal to base address plus offset. This is the formula. Physical address is your base address plus offset. Now you can see physical address is one dimensional, and how it is converting two-dimensional thing, that is your base address plus offset. You are adding and you are making this physical address. Okay. So, and what is your base address? This is your segment address from where you are starting. So let's see in hardware how it is using. From CPU, here you can have this S is you go for your segment number or segment name. D is your displacement, or you can think of your offset. Okay. D is displacement or an offset. So here you can see the segment table. Your segment will go here and check the limit with the segment table. It will check the base from where we can go for, and then if we check if this displacement is less than your limit, means the area of your where you, what is the limit of your container, how much area you can cover, that limit you will take, and then displacement will check with the limit. If it is less than, then what will happen? There is an address error. And if it is yes, means if it is not less than, there is an error. If it is less than, then yes, we will add the base address with the offset and we will get the physical memory. Got it? So here is a CPU, here is a segment. It will check with the limit, it will check with the limit and the base. So here is a segment table. Thing happen. Now I'm visible. There is some issue with the internet. Let me know, am I audible and the screen is visible? Am I audible? Okay, thank you.
Yes, sir.
Okay, thank you. So what we were discussing, that here is a segment. Segment number is there. We will check with the limit. If segment, we will check the displacement with the limit. If it is less than, then you will add the base address and get the physical address. If it is displacement is greater than limit, means you are trying to access the address which is not in your area, then there will be an error. So let's see how we will see a numerical how we will convert the logical address into a physical address. So here is a question for you. As you can see, what are the physical addresses of the following? This is two-dimensional array, that is your logical address. First one is segment number, and second thing is your displacement or your offset. So 0 segment displacement is 430, then segment 1 displacement is 10, then segment 2 displacement is 500, segment 3 displacement is 400, and the last one segment 4 and the displacement is 112. And now here this segment table is given to you where segments are placed 0, 1, 2, 3, 4. Their starting address, that is base address, is given, that is 219 for 0, 2300 for 1, 90 for 2, 1327 for 3, 1952 for 4. And this is the length, that is your limit. Means the value which is less than 600 can be placed only, otherwise there will be an error. Similarly here 14, 100, 580 and 96. Now you have to tell the first one, that is segment 0 and the offset is displacement is 430. Can you tell the physical address? Physical address is your base address plus displacement. So can you
So
try?
649. 649.
649. How you go for this 649?
So base plus offset, but it is it.
First, firstly, what we will check? Firstly, you have to check with length. What?
Yes,
Displacement is
offset.
less than length or not? So
Yes, sir.
let's check if 430 is less than 600. And why we are looking for 600? Why we are not looking for 14, 100, 580 or 96? Why we check this 430 with 600? Tell me. Can anyone help me?
They are
Anyone?
less because they are less than 430.
Yes, my question is why you check 430 with 600? Because we are
So
looking for
because
segment 0, right?
Yes, sir.
Because we are looking for segment 0 only. So we will check the all things with the segment 0 only. That is, we will see the base value of segment 0 only and the length, that is your limit of your segment 0 only. Got it? So now this condition is true. Then what we have to do? Physical address is equal to base address plus offset. Then base address is your 219 and your offset value is 430. Got it? So what is your physical address? 649. Everyone all good? Everyone? Do you get the concept?
Yes, sir.
Yes. Now go for the second one. Go for the second one. 1 comma 10. Tell me the physical address. Second one. What is the physical address of second one? This 1 comma 10. Tell me. Tell me 1 comma 1.
230.
Yes? 2 3.
2310.
2310.
Exactly. Exactly. So here was the 1 comma 10. 10 is less than 14, right? Because we are looking for segment 1. So for segment 1, length is 14 only. So now formula is physical address is equal to base address plus offset. And do you remember that only I can write in the short PA and BA in examination what you have to do? In examination what you have to write? Tell me. In examination what you will write? Physical address is equal to base address plus offset. Got it?
Full
So here base address is 2300 and the offset is 10. So the answer is 2310. Now go for the third one. Go for the third one. Tell me third one. Go for the third one. Yes, are you there?
yes, so it will give error because
Why?
offset is greater than its length. Displacement is greater
Exactly.
than its actual length.
Exactly. Here you can see that 500 is greater than 100. 100 is the limit of the segment 2. And here the situation is that you are trying to access an address which is not in your control. So there is an error, that is trap. Okay. Now go for the next one. That is 3 comma 400. What will happen here?
1727.
Okay. And go by step by step. Firstly, you will check 400 with the length, right? And length is 580. Got it? So you will check that 400 is less than 580. Condition is true. So we will go for physical address equal to base address plus offset. So 1327 plus 400. So here is the answer 1727. Now the last one. The last one. Come on. The last one. Are you there? The last one. Tell me. Fifth one. Are you there?
Trap.
Trap, exactly. Because 112 is greater than 96. So there will be a trap. So everyone is all good. How to do this numerical? Done?
Yes, sir.
Okay. So we are done with today's class.